Hi everyone, myself Dr. Manjunath Singh, working as an assistant professor in the Department of Chemistry, RV College of Engineering, Bangalore, India. In this video today, I would like to discuss about thermoplastic polymers by taking two important polymers, polycarbonate and as well as AcrylonitrileButadieneStyrene polymers, the synthesis and their properties and various applications of these thermoplastics will be discussed in this video. What are thermoplastics? Thermoplastics are also called thermo-softening plastics. As name suggests, with respect to heat, by varying heat, these polymers can be molded into any shapes, because upon heating, that polymer becomes flexible, and upon cooling, it becomes a rigid solid state. So again, if you heat it, it becomes soft and flexible. If you cool, it will come back to its original state. It is a reversible with respect to heating effect. Such polymers are called thermoplastics or thermo-softening plastics. Most of the high molecular weight polymers exhibit this property. Most of the thermoplastics are actually a high molecular weight. Okay. The polymer chains associate through intermolecular forces. Therefore, they can be molded, and they're also flexible upon heating. I'm going to discuss two important polymers in this video. Thermoplastic polymers. One is a polycarbonate, other one is ABS, AcrylonitrileButadieneStyrene. So let us look at one by one. That is, the first one is AcrylonitrileButadieneStyrene. It is also called ABS polymer. So these materials are complex blends of all the three monomers. It is also an example for copolymer or mixed polymer, in which we use three different monomers. One is acrylonitrile, other one is butadiene and styrene. By varying the composition of these three monomers, you can have varieties of ABS polymers. Okay. So in most of the ABS polymer, acrylonitrile and styrene are grafted onto butadiene backbone. Okay. The product also contains unreacted polybutadiene and some percentage of acrylonitrile styrene copolymer. So it's not easy to get a pure product in this, because it involves three different monomers. Hence, it will have, the final product will have some unreacted polybutadiene and as well as some newly formed copolymers of styrene and acrylonitrile. Okay. So, and this polymer has very high impact resistance, good stiffness, excellent surface quality, high dimensional stability at elevated temperatures. One of the drawbacks of this ABS polymer is its lack of transparency and poor weathering resistance, and also poor flame resistance. So let us look at the preparation of this ABS. ABS is prepared, as I told you, by using three monomers, acrylonitrile, butadiene and styrene. Firstly, styrene and acrylonitrile are added to polybutadiene latex, and the mixture is heated to about 50 degrees centigrade, and to allow the monomers to absorb and then start polymerizing. So this follows free radical polymerization. For that, to initiate the free radical polymerization, you need to add some initiators. Okay. So a water-soluble initiator is added and heated at 50 degrees centigrade with constant stirring. The resultant mixture of ABS is extracted, washed, washed and dried, and it is used for further applications. So this is the actual reaction in the polymerization, free radical polymerization of ABS polymer. So ABS require three monomers. One is styrene, butadiene, this is a butadiene, and this is acrylonitrile. Okay. You can get ABS polymer of different types that depends on XYZ composition. So this is a styrene part, and this is a butadiene part, and this is acrylonitrile part. Here, the double bond present in this double bond, and these two double bonds and this double bond are involved in free radical polymerization. So this there is a homolytic fission of this pi bond As a result of that, this will have one free radical and this will have one electron. And here also this will cleave, and this carbon will have one electron, this carbon will have one electron. Similarly, this pi bond will break down homolytically, and then so this carbon will have one electron, this carbon will have one electron. So the electron present in this carbon and the free electron present in this carbon atom form a double bond here. So actually there is a double bond is missing over here. Please remember. So then this electron combines with this, and this electron, similarly, there is a breaking of this bond, and hence the formation of ABS polymer. Okay. So this ABS polymer, actually, please remember that this should be a double bond here. It is missed. Please note down. There should be a double bond here. Okay. And this ABS polymer will exhibit different properties based on the composition of X, Y, and Z, X, Y, Z. So this polymer exhibit excellent impact resistance even under the load, good machinability because it's a thermoplastic, it can be molded into any shape, excellent chemical and thermal resistance, and it's easy to dissolve and make it dissolve along with the paint and glue, and good strength and stiffness, and relatively low cost compared to other thermoplastic materials. So, and this ABS polymer is used in piano movements in musical instruments, and also in tattoo inks. Less than 1 micrometer ABS is used in tattoo inks, and also for 3D printing, colorants. It is used as a colorants in 3D printing, and even some toys, medical devices, kitchen appliances are made up of ABS polymer. So this is how they appear. These are all colored ABS, and this is actual ABS polymer. You can, by adding some dyes and pigments, you can have different ABS with different colors. This is about AcrylonitrileButadieneStyrene polymer. Next, another important thermoplastic, that is polycarbonate. So polycarbonate is also another thermoplastic, and it is it has a carbonate group in the backbone of its polymer chain. Therefore, it is called polycarbonate. So this is a prepared by using two different monomers. One is a bisphenol A. This is bisphenol A. This is phenol, and this is phenol, another phenol. Because of the presence of two phenols, we call it as a bis. Bis means two phenol. A represent, it is actually the acetone part. Bisphenol A is prepared from 2 moles of phenol reacted with 1 mole of acetone. You will get this bisphenol A. So bisphenol A in the presence of NaOH, it forms bisphenoxide ion, O minus and O minus, and this O minus reacts with phosgene. This is phosgene. This is a carbonyl carbon, is having electropositive in nature because of partial positive charge, and this is partial negative charge. This phenoxide ion is undergoing electrophilic substitution here, and there is a cleavage of this bond in the presence of NaOH and also tertiary ammonium cation. There is a breaking of this bond, and this O minus is going to substitute here. So O minus, and similarly another phenoxide ion is going to form, and the polymerization continues, leading to the formation of OCOO. This will be CO in the next repeating unit. So therefore that will be carbonate. So it is called polycarbonate. Because the poison is actually very poisonous in nature, this bisphenol A, polycarbonate resin can also be prepared by using dimethyl carbonate. This is a dimethyl carbonate. Instead of using phosgene, people have prepared polycarbonate using this dimethyl carbonate. These are dimethyl, and this is carbonate, CO3. So here again we are using bisphenol A in the NaOH solution, and the mechanism is same, and you will get polycarbonate resin. Okay, so this is the first step, the synthesis of that is bisphenol A reacts with NaOH and forms phenoxide ion, then undergo nucleophilic substitution at carbonyl carbon of phosgene or dimethyl carbonate, and leading to the formation of polycarbonate polymer. This polycarbonate has high impact resistance, high heat resistance. It can withstand the temperature, high temperature. And very important property of this polycarbonate is it is transparent. And it is also relatively stable, chemically stable, and it has high serviceable temperature. Okay. So these are the applications of polycarbonate. Polycarbonate, because of its transparency and it has high impact resistance, it is used for making walls, glass houses, and even the CD cassette drives are made up of polycarbonates. These are all glass houses are made up of polycarbonates. They are lightweight, high strength, transparent materials. And also it finds applications in medical syringes. Medical syringes are made up of polycarbonates. Okay, you can see this slide is showing the applications of this polycarbonate in airplane windows. You might have seen suitcases, automobile interiors and exteriors, medical, as I told you, syringes, lenses for the glass and sunglasses, uh, game insoles, consoles, roofing and fencings. So this is about thermoplastics, that is ABS polymer, preparation and properties and application, and polycarbonate polymer, preparation, properties and applications. If you find any doubts or clarifications, you need any clarifications or questions, please email me using this email IDs. Thank you very much.